Okay, this is the first part of two videos. The first one is about using ratios to solve problems. I'm going to quickly go through the way I would do it with equivalent fractions and also what they call the unitary method, which is where you find what one object is worth. I think you should probably know these fairly quickly and easily anyway. Second video will go on about what direct proportion is. So, video number 1, as an example. A student can swim 8 lengths in 48 minutes. At the same speed, how long will it take her to swim 5 lengths? Well, my proportion method says that I can do it two ways. I can do lengths and time, and they're two equivalent fractions. You line up, you say, what do I know? I want to know how long, so the x is on the time side, and that x is with 5 lengths. The student can swim 8 lengths in 48 minutes, so 8 lengths is the same as 48 minutes. If you set it up the wrong way over, the fraction can just flip over. It'll still work, because basically you cross multiplying by x to move everything around. Okay, but it's easy if you can place the x. Rearrange, so we multiply both sides by 48, and we get x equals 48 times 5 over 8. I don't need a calculator for this one because 8 goes into 48 6 times, so x equals 30. Okay, so that's using equivalent fractions. The second one is what they call the unitary method, which is a very similar idea. And what it is, it's almost using, or we'll use ratios. If I know we've got lengths, also I'll just go back and do one other thing. You can line these up in a different way. You can say lengths and time horizontally. Okay. If we do length and how long it takes, 48 minutes, that's time. You can solve very similarly to find out what one length is. One length is, divide both sides by 8, is 6. And then I want to know what 5 lengths are, so I'm going to multiply by 5. And 5 gives me 30. And that gives me my solution there, same number of minutes. Either method's fine. One thing with this method though, as long as you've got 2 numbers filled in, I could actually use these 2 numbers together, add them, and I would get 9 lengths takes 54 minutes. So you can add 2 whole lines together. It's like adding equations. It's the same rule. As long as you know both sides, you can add the things together. And as long as these things are supposed to be representing the same thing, we can solve the problems by adding whole rows. So this is the unitary method that they were talking about, and we say that's going to be 30 minutes. Recipe for samosas requires 400 grams of flour for 8 samosas. How much flour is needed for 3? So again, I need samosas and I need flour. You don't have to write the titles, it's just writing things out. I want to know how much flour is needed. And the flour needed, if I want 3 samosas, I know 8 samosas is 400. Again, I can multiply by 400. And that leads me to x equals 400 multiplied by 3 over 8. That's going to be 50, so that's 150 grams. Let's go on down a little bit, do it by the unitary method. So we start with, now we say we know how many samosas and how much flour. And we've got 8 samosas is equal to 400 grams of flour. Now you can extend this to give us more colons and more units. So a samosa needs some meat, it needs peas, it needs water. So you can actually put all those ingredients and solve this problem the same way. And in exactly the same way, you can write equations that are also equal. So these two things are exactly the same basic method. You can write a load of these side by side. And in a minute I'll show you why that's useful to know with the equations things. So Somoza, need to find out what one of them is. So we share by 8, which is 50 grams. From the 8, I now want to know what 3 are. So multiply by 3, 150 grams. Okay, so you might find this easier. This is a lot easier when we don't have nice numbers to play with. The reason this is useful, and these techniques are useful, it's to do with sectors and parts of a circle. And there's a few bits to know. There's an angle in the middle. We've got the arc length, and we've got the area of the sector. Both, if we deal with that using this equation form, sorry, not the ratio, it was this equation form that gave me, is why I like introducing this idea here. So the angle, first of all, the fraction of a circle is the angle, I'm going to call it theta, and on a full circle, that's the part on top, and the circle on the bottom. So the full circle is 360 degrees. That is equal to the percentage of a pie chart, P over 100, is also equal to the area of the sector. So this is area of a sector, and that is over the area of a full circle, pi r squared, which is also equal to the length of the arc, and that is equal to over the circumference of the circle, which is pi r, pi d, some of you all know. I tend to stick to using 2 pi r, but it doesn't matter. And that gives, this equation here is really useful for working out parts of a circle, and it's the same maths as we've got here. So the reason I'm encouraging you to use this sort of method is it builds up nicely for the sectors. That'll do.